Hello and welcome back. In the previous video we looked at expressions typed into the Python shell, and this allowed us to treat Python as essentially a glorified calculator, but it didn't offer us any ability to store data. And as we know, computers are very good at storing data and manipulating that stored data. So we obviously need a new construct. And that's the topic of today's video. We're going to talk about the assignment statement, which is tremendously important, absolutely basic in all programming languages. And it's very important that we understand it correctly. And unfortunately, it's quite easy to misunderstand how assignment is working. So the general form of our assignment statements is some variable name equals some expression. And we see one particular example here. If you remember from last time, an expression simply yields a value. So if I type in my expression here, 200 integer division 2 minus 1, that's going to be executed by the Python shell to yield a value, and that value will be 99. Okay, but we haven't stored that away, we haven't used it, we haven't made it available for future use. So instead what we'll do is we'll use an assignment statement. And the form of the assignment statement is some variable name, and in this case the variable name is my age, equals, that equals sign says, hey, we're doing an assignment statement right now, so the variable name equals some expression on what's called the right-hand side of the assignment statement, right-hand side being on the right-hand side of the equals. So nothing was returned this time, because the assignment statement has no associated return value with it. It's done an operation and it's recorded some state, and we'll talk more about state in a future video. But for now, that's a preview of assignment statements. They are of the form variable name equals some expression. And there are some rules for what's a legitimate variable name. The rules are the variable name must begin with a letter or underscore, followed by any number of alphanumeric characters, letters, underscores, or digits. So A 1, 2, 3 equals 42. On the right-hand side we have an expression that is 42. On the left-hand side we have a legitimate variable name, so this will be successful, although we can't see the value associated with this at any point, or at this point. But 1 underscore ABC equals 999. This is not a legitimate variable name, so we will get a syntax error from this. The reason it's a syntax error is we have an illegal variable name. It begins with a digit rather than beginning with an underscore or a alphabetic character. Okay. So let's look in detail at what Python does with an assignment statement. It does two things, each of which involves multiple steps. So if we go back to my age equals 200 integer division 2 minus 1. What happens here? It works out the value of the right-hand side first. So that's this component here. It's the expression on the right-hand side of the equals. Okay, the statement as a whole consists of variable name equals and then the expression on the right. So the right-hand side will be evaluated, and this will yield a value, as expressions did in the last video. That value then goes on to the object store, the computer's memory, also called the heap, so it's got several equivalent names. Okay, so the value 99, the value that's worked out from the expression on the right-hand side, goes on to the computer's memory. And that value, as we said in the last video, has a type associated with it. In this case, the type is an integer. 99 is an integer value. The second thing that happens is it assigns a name to the object, or more accurately, it makes a variable name refer to that piece of the computer's memory. So, if we haven't seen this variable name before, and we haven't in this case, my age currently doesn't exist, we add the variable name to the dictionary of variables. Okay, That's the first thing. We add a new name to a dictionary of variables that we know about. And then it sets that dictionary entry to point to the new object. Okay, so if we draw out this expression, this statement, I'll run the statement, we see no return value, but something very important has happened. The right-hand side has been evaluated, yielding a new int object that is on the computer's memory. Okay, so we're drawing out the computer's memory here. And we also have a dictionary that may contain a whole bunch of other variable names. At the moment, this is the only one that we can see. And myAge refers to that value. There's a good learning aid, Python tutor, that uses that you can use, and it includes something called a live programming mode. I'll just show it to you quickly. So this is what pythontutor.com looks like. We can start visualizing our code now, and if I type in my code, myAge equals 200 integer division 2 minus 1, and I ask to visualize my code, what you'll see is a picture that looks very similar to the picture that we have in the slide over here. So I can step forward or backwards in this code. So at the moment it hasn't started executing anything. If I step forward, what you'll see is myAge. I'm calling it a dictionary, they're calling it a frame. Meaning's the same. And it's saying that myAge now refers to the object on the heap that is an int that has the value 99. So Python Tutor, you might find it useful to help you visualize what's going on. So what is this thing, the reference? I'm drawing out this reference using arrows, and I'm being quite careful in my language to say that the variable myAge refers to some data, and that data in this case is the value 99. So what the reference actually is it's just a numerical value in the computer's memory. So the computer has a large set of random access memory, and the Python engine has access to a portion of that computer's memory. So if we've got a 4 GB memory, well, essentially the bytes are addressed or numbered 0, 1, 2, 3, 4, 5, and so on, all the way up to 4 GB or 12 GB, however much memory your computer has. Each of these bytes is called an address, and a reference to an object is simply the value of the address at which that data is stored. Okay, in Python we call that the object's identity. So the value 99 is actually stored at address, let's say it's 1,042,000,042. Okay, the value 99, the object on the computer's memory, is at address 1,042,000,042. And my dictionary entry for myAge stored somewhere completely different in the computer's memory. But what it's storing there is the value 1,042,000. So essentially it's saying myAge stored here, and it's a reference to a completely different part of the computer's memory. Okay, so a dictionary entry consists of a variable name called a string, together with, and we'll see more about strings next week, together with the identity of the object it references. That might seem overly complex, and that's why both the Python tutor and I in the previous slide are using these arrows to show these references, rather than showing, hey, this is at location 1,042,000,042 and this value is actually 1,042,000,042 to achieve that reference. I'm just drawing it out as an arrow. Okay? This distinction between referencing objects and storing them directly is actually really, really important later in the course. So it's quite easy to form a misunderstanding of assignment that what myAge is actually a name for a box and the value of myAge is stored in that box. That's not quite right, and it's importantly not quite right. So it's important that you get this notion that myAge is a name on the dictionary and it refers to address elsewhere on the computer's memory. Thank you for now.